In this video, we're going to look at a couple more ways for evaluating limits. So let's go over methods for finding limits. Now, from a previous video and previous section, number one was numerically, and number two was graphically. And those are good techniques, especially with calculators. But of course, if you don't have a calculator, especially on the AP exam, you're in the non-calculator part. How do we evaluate a limit without having to go through all this work? So number three I'm going to put down, and it's the first thing we always try. We're going to use substitution. So let's look at an example. So if you remember, we had this function, f of x equals x squared minus 3x plus 2 all over x minus 2. And this is the example that we used in a previous video. That was actually the one that we used for our introduction to limits. And so we know that the limit as x approaches 2 of f of x was, I believe it was 1. But if you remember, when we put in 2, it became 0 over 0, so it was undefined. We had to go through that whole process. Now let's look at, well, what is the limit as x approaches negative 2 of x squared minus 3x plus 2 all over x minus 2. Now in some ways this is kind of a trick question because, at 2 we evaluated at x equals 2 and we found it indeterminate. So we had to go through this whole numerical analysis process. But in this case here, you can kind of, you'll always try substitution first, because if you can evaluate it and you get a number, then there's a good chance that's the limit. So let's go ahead and put it in. We have a negative 2 squared minus 3 times negative 2 plus 2 all over a negative 2 minus 2. And so what happens is we end up with 4 plus 6 plus 2 all over a negative 4. So it says 10, 12 over a negative 4, which is a negative 3. And that's our answer. So graphically what's happening here is, if you remember, so here was our point of interest, and here's our graph. So at x equal 2, we had an indeterminate point, so we had to go numerically from both sides to figure out what was the limit, which was 1. But at x equals negative 2, let me draw this up a little bit more. Notice that as we approach negative 2 from both sides, it is approaching negative 3. However, if we evaluate f of negative 2, we also get negative 3. So if you have a function, every function has limits, and if you have a function that's defined for every point, then when you evaluate the function at that number, that is also the limit. Of course, usually if you can evaluate a number at a point, you're not worried about the limit. The limit is about what happens if you can't evaluate at that point. But anyways, that's kind of a nice little trick question that comes up in the book or on tests. And it's, well, try substitution first. If substitution works, then you most likely have your limit. Let's try another example here. This is kind of a different example. So the limit as x approaches 2 of f of x equals 10, and the limit as x approaches 2 of g of x equals 3. If h of x equals 2, well, let me put it down here. If h of x equals 2 f of x plus g of x, find the limit as x approaches 2 of h of x. Alright, so here's kind of an example that goes with a little bit of substitution. We're given that the limit of some function f of x as x approaches 2 is 10, and we're given some limit as x approaches 2 of g of x is 3. We're also given that this h of x, a new function, is a combination of f of x and g of x. It's 2f of x plus g of x. And now we want to find the limit as x approaches 2 of h of x. So the limit as x approaches 2 of h of x is going to be the limit as x approaches 2 of 2 f of x plus g of x. So we have our limit, and that's the question, and then all we did was we substituted in what h of x is. And now we can split this apart. So this is going to equal 2 times the limit as x approaches 2 of f of x plus the limit as x approaches 2 of g of x. We know that the limit as x approaches 2 of f of x is 10, so we're going to have 2 times 10 plus the limit as x approaches 2 of g of x is 3. And so we end up with 23. All right. So this is a fairly simple problem. The idea is that if you have two functions that are being added, you can add their limits if they both have limits. I think another good point about this problem here is a lot of you probably would want to just go 2 times 10 plus 3 and write down the answer. You are getting to a point in math where you do have to show some work. We showed a lot of work in pre-calculus, but you got to demonstrate your knowledge through this. So don't just go straight to this part here. Make sure you do write down certain components of these.